Good morning, friends. So today problem is cherry pickup 2. Problem number is 1463. It is a hard problem and belongs to the dynamic programming problem, right? So the statement of the problem is you are given a rows into columns matrix grid representing a field of cherries where grid ij represents the number of cherries that you can collect from the ij cell. We have two robots that can collect cherries for you. Robot is located at the top left corner 0 0 and robot 2 is located at the top right corner 0 comma calls -1. Return the maximum number of cherries collection using both robots by following the rules from from a cell ij. Robots can move to cell I plus 1 j minus 1 I plus 1 j or I plus 1 j plus 1. When any robot passes through a cell, it picks all the cherries and cell becomes an empty cell. When both robots stay in the same cell, only one takes the cherries. Both robots cannot move outside of the grid at any moment, and both robots should reach the bottom row in grid. So what all the stuff trying to say is, if robot 1 is here and robot 2 is here, the robot 1 can move to forward, left, and right. And robot 2 will also be same choice, left, straight, and right. But they should not interact with each other. Suppose 3 has a 5 and 1 is also a 5, and 5 is maximum. But any one of them can select 5, not both of them. That's why robot 2 is selected 5 and robot 1 is selected to 2. And this is the again the example 2. If robot 1 is select 2, then it will never reach to the 9, which makes inefficient solution, because here is specified that return the maximum number of cherries collection using both robots by following the rules. So we need here the maximum number of cherries. And I hope you know that when the questions specify that the maximum number of something and minimization of the number, then you should think about the recursion and dynamic programming. Any dynamic programming means we have to deal with the recursion. If you good in the recursion, then solution can be possible, you can do here, right? Perfect. In topics, you can see here dynamic programming. There is also hint specified. Use dynamic programming. Define DPIJK, the maximum cherries that both robots can take starting on the ith row, and calls J and K of robots 1 and 2 respectively. I hope you understand the statement of the problem. Let's see the code. I already wrote the code for the saving the time here. So this is our the function is given by the Leetcode, right? And here is what we are doing here. We are taking the number of rows, number of columns, then we are also taking the memo. This memo is for here for improving our time complexity in the terms of the recursion. When there is a there in one recursion has one another more recursion, then maybe it's possible that we are recalculating the same thing. So it is very time consuming and creates a roster time complexity. For improvement, we are doing here memo. Okay, in rows calls and memo dot resize, we are resizing our memo. We are even do here, but for efficiency, for efficiency to see, we are doing here return helper function here. So here is helper function. What helper function do here? It takes four parameters. First of all, grid, then 0 0 and call -1. This is a robot A where it starts begin to move, and this is robot B where calls where robot 2 begins to start. If any of the robot uh, go outside of the grid, then we have to return 0. And if our current row is equals to the grid dot size, return 0. What it states that here, if we are reach last row and go outside from the grid boundary. Okay, and here is mem dot size. If it is calculated, then don't need to move forward to recalculate it. Then we are storing our result here, and it here is we are doing for loop. Robot A call -1, robot A call +1. Why are we are doing? Because there are three possibilities. If it is 0, then -1, -1, 0, and 1. There are three possibilities: left, straight, 10, right. That's why. And finally, we are storing our max answer. We are storing only max answer. This problem is solved by the DFS approach, and here we are just returning our answer in that to the if memo current will be initialized with the result. So whenever the memo robot A call, robot B call again comes, it will be not recalculated. So let's submit it our problem. It's done. 90 days is completed. I hope you like our solution and explanation. And if you are really enjoying, then please share and comment it down. Okay. I hope your day will go fine. And please press the subscribe button. Right. Thank you so much.